Mr. Nesbitt. Kirk Nesbitt is the technical advisor of the Canadian Association of Broadcasters. Canadian Association of Broadcasters is the national voice of Canada's private broadcasters, representing the vast majority of Canadian programming services, including private radio, television stations, networks, specialty, pay, and pay-per-view services. Kirk is a professional engineer providing services to broadcasters, systems integration, and equipment suppliers. He's the Broadcasting Committee Chair of the Radio Advisory Board of Canada and the Chair of the Humber College Broadband Convergence Lab Advisory Committee. Let's not try that again this early in the morning saying that quickly. So, ladies and gentlemen, Mr. Kirk Nesbitt.
Good morning. Thanks for the opportunity to chat with you today. And one just quick update, Jim, and I missed that in the bio that I gave you. I've stepped down as chair of the Humber College Broadband Convergence Lab. Still participating in their advisory committee, but after 2 years as their chair, I've handed that off to Michael McEwen, who's going to provide his leadership to that now. So I just thought I'd mention that. Okay. So let's get going. So you've covered my first slide for me, thank you. But did want to point out that participation in the CAB Technical Coordinating Committee is open to all CAB members, and certainly encourage you to participate. Just get in touch with me if you'd like to join in. Our technical committee is, we have a main committee chaired by Dennis Barrio, who you know very well. A small hiatus when he retired from full-time work, but thankfully has agreed to continue on with us, and it's welcome. Our radio subcommittee chair is Bill Stovold from Pattison Media, and the television subcommittee chair, Clint Hollinger from Chorus. Now, most of our work that we do with ISED is channeled through the Radio Advisory Board of Canada. That's our main liaison pipeline into the department. And so as Jim mentioned, I chair the Broadcasting Committee, and we have two subcommittees, the radio subcommittee chaired by Rob Brown of Pattison Media, who's fortunately here at the conference, and our Safety Code 6 subcommittee chaired by Julie Bergeron of CBC Radio Canada. So I'll get into some ISED regulatory updates. I realize this is a little dry and boring, but face it, the whole presentation is dry and boring, so we'll just have to work through it. Okay, so this is sort of a long-standing consultation from the department regarding signs and access controls at your transmitter sites. This, the proposal from ISED would make existing compliant stations grandfathered for 7 years, but then more stringent requirements would kick into play for any new stations and any changes to your station. So even within the 7-year period, if you had a change of technical facilities, you would have to potentially upgrade to these new requirements. And we had an initial review from ISED with the RABC in 2022. So you can see this has been kind of a long process. We provided feedback to them then, which they then took away and launched a public consultation in October 2023, which was open to all Canadians to provide input if they felt inclined. We filed comments in January 2024, and ISED published all of the responses that were filed with them in March 2024. So there were no comments received from the general public. All of the comments were from stakeholders, spectrum users, such as broadcasters, mobile operators, and other radiocom users. And it was very interesting that the responses were very consistent with the CAB and the broadcaster position that a document like this is extremely difficult because no two sites are the same. Everything has to be addressed case by case between the differences between AM stations with their huge properties and multiple towers and FM repeaters that are up on mountaintops that you can only access by helicopter. You can't try to capture that all in one thing. And that the proposed guideline was too stringent to deal with those extraordinary differences between sites and rocky terrain and incredibly impractical to implement some of the proposals. So this, we don't have a final decision from the department yet as to what the outcome will be, but I certainly don't expect that the issue is closed. And in the meantime, I think it's really important for all of us to just be really prudent and responsible with your transmitter sites, that when you are making changes or if you do become aware of problems at your site because of damage from a windstorm or who knows what, that you do your very best to demonstrate that you're protecting the general public in the most responsible way until final rules and regulations come out. So then, interestingly, in the meantime, ISED issued an update of CPC 32401, which is the administrative monetary penalties, which they can administer to any spectrum user, but it can be applied to broadcasters if they're in non-compliance. And so being in non-compliance at your transmitter site for not having proper protections like fences and the like can be a situation where you would be out of compliance. The department does not issue these very often. You have to really be uncooperative to get one of these, but all the same, that they have the authority to do it. And one of the other important details is that they also have the ability to publish those results so that it will be available to anyone to know that you have been assessed one of these infractions. So just be aware and be responsible. Probably the biggest update from ISED in this past year has been an update of BPR3, which is the application procedures for FM broadcasting, and it furthers the transition to prefer online applications, and there were other editorial changes, but the most important change was the incorporation of HD radio into the FM regulations. And most of the elements of BC 21, which were the experimental requirements for HD radio on FM, have been incorporated. A slight change that the interference analysis provides 3 dB more protection to adjacent channels, which was quite some debate about that, but I think it was some of the study that had been done by CRC years ago that provided the basis for that. The maximum ERP of digital sidebands expressed in dBc for each service, because in HD radio there are various service modes that you can operate. The simplest for one digital program service, MP1, you can operate at a minus 13 dBc per digital sideband, so meaning minus 10 dBc for the total of both. And then for the different service modes, there are slightly different maximum power levels for the digital sidebands, as shown in the table here. But also, it provides for asymmetric operation as well, so that if your station has a challenge meeting the interference protection on adjacent channel on your upper sideband, you can reduce your digital power in that direction, but not compromise your digital power to the lower sideband if you meet the protections there. On the TV side, ISED issued some editorial updates to BPRs 4, 10, and 11. BPR 4 is the TV regulations for analog TV broadcasting. BPR 10 was the initial DTV broadcast regulations, and then BPR 11 was introduced to facilitate the television repack to vacate the 600 megahertz band. So none of that has been sort of tied together and updated now that the TV repack is complete at the beginning of 2022. And so this was just a clarification that they're not accepting any applications for new analog stations, although there are still analog stations that continue in operation. And that any modification of a DTV station still has to meet the requirements of BPR 11 until we get the tidy up job done, which I imagine will be coming in due time. A couple of other interesting things. I thought Rob Peretti's presentation yesterday was very interesting to illustrate the complexity of wireless microphones that you're all using more and more and more. And when you think about in some of your studio complexes, the number of wireless mics that you're using throughout the facility is just growing and growing. And when you go to live performance, you can see that the effect of that as well. But one of the changes this year is that RSS, which is radio, David can help me with, what does RSS stand for? Radio Standard something. Nope. But close, but we're both close. Anyway, these two regulations have been updated to, for wireless microphone equipment to include a new standard, which is wireless multi-channel audio systems, where multiple audio channels can be incorporated into one 6-med channel. So, go ahead.
Received signal strength, RSS.
Nope. I'm sure you're right, but that's not what the ISED version is. Yeah. It's too broad of a search. Okay, moving on. Emergency alerting. It's also been another sort of important year, an active year in emergency alerting. As you're all aware, and hopefully not directly impacted too much by some of these events, but climate events across the country are just getting more frequent and more extreme, with wildfires and flooding and the number of events. I did actually, if you go to the Alert Ready site, which is the public-facing site of emergency alerting that is put up by Pelmerex, it has information in there that you can look at the number of emergency alerts in over the years by province, and it lists what they were, whether it was wildfire or flash floods or what it was. And the count right now is a little over 600 so far this year. The total for last year was a little over 1,000. So we're kind of on track that there aren't actually more emergency alerts going out this year compared to last. But it does seem that these events are getting more extreme. So definitely top of mind for all of us. The national test on May the 8th included the first time that Public Safety Canada issued one test alert issued across multiple provinces. Not all provinces participated in the test, but I think there were six or seven maybe that were included. And so that was an important test. If there was ever something of national security that justified an emergency alert to go out, you would need to know that could be handled accurately. So the test was successful in the provinces that participated. There is an interesting sort of piece of this that has yet to be updated and included, is that there is a national alert SGC code, which is the standard geographic categorization, which is, these SGC codes define the area that you're broadcasting the emergency alert. So there is an SGC code 00 that defines all of Canada instead of an entire province, which some provinces do their Amber Alerts by the entire province, or they can target down and down and down to smaller and smaller regions. So that's not currently active because the current alerting hardware that you use hasn't included that yet. So that'll be something that's going to have to be improved in the future. A couple of other updates is that NRCan, which is Natural Resources Canada, has been in the process of quietly testing their system to issue emergency alerts for earthquake warnings. And so they're now fully capable of issuing that, but I think they're managing a slow rollout to make sure that it's handled in a very careful way. But it's now on the list of things that they're capable of doing. And the last thing, and an important one for all of you, is that Pelmorex, who operates the NAD system for emergency alerts, is ending HTTP support. And some alerting hardware we've discovered, because many of you bought your initial alerting hardware back in 2014, 2015 when emergency alerting started. And so it doesn't support HTTPS, and you would actually have to replace your gear to be compatible. So check your gear, because I think this change is they've been running the two in parallel for quite some time. I think they're dropping the HTTP support next month, and so make sure your gear is capable of HTTPS and operating. I always reuse this slide because I just like it so much. Emerging radio platforms. Because listening to radio is available on devices primarily used for other purposes, like the PC at work, your smart speaker at home, smartphone when you're mobile, and now the connected car. And I've talked to you all in the past about the importance of metadata and how it helps radio be on a level playing field with satellite radio and with the streaming services like Spotify, who are providing a good level of metadata to provide logos and album art and title and artist. And while broadcasters are doing it and getting better, we're not doing it enough, and it's not good enough. And so it's always been important to me to try to reinforce that and encourage broadcasters to continue on. And I've been in discussions with the North American Broadcast Association, who want to develop some webinars or sessions to explore the business case opportunities, to give station owners and managers the justification they need to put in the time and effort and investment to do this well. And so we hope to find some examples, because I believe that some of the U.S. broadcasters in major markets are ahead of Canadian stations in this regard, of being able to generate revenue out of their metadata, by supporting text and visuals along with their advertising and the like. I've had some early discussions with Radio DNS to create a national database of PI codes, because this has always been a challenge with RDS, is that not only does the receiver behavior in cars can be a little bit different from manufacturer to manufacturer, but also broadcasters are notoriously bad for keeping it up to date and getting it right. So two things that happen very obviously is that your RDS encoder fails, somebody gets the new one out of the box and puts it in and gets it operational, but forgets to program the PI code. So it's got some default code in there that is totally wrong and messes up the receiver for listeners. The other is that you go through a format change and you change your call letters because of the format change, but you don't update the PI code. And so the NAB in the U.S. has done exactly this. They commissioned our Radio DNS to create this database that would be, a live managed database that they can validate every station who puts in their PI code, or you can go to this database and check what your PI code should be. And in fact, the department, I said, does publish the list of PI codes for call letters, but it doesn't deal with the exceptions. And there are, exceptions, some of them for very good reasons. One example of this is that there are some like traffic services that are operated on RDS by like I think maybe Garmin. And so once they've got the system up and running, which is relying on those PI codes of the stations that they're using for this traffic service across the country, then very difficult to manage a change to modify PI codes. So, there's some challenges around it, but it's an important thing if you want to have good behavior of the radio in a car, and hence a good experience for listeners. Also point out that the NRSC has done a lot of work on providing guidelines and handbooks for using metadata, and I think last year they provided one for metadata for FM and HD radio, and they've taken that a step further and put a lot of work into a guideline called G304, which is a metadata handbook for streaming audio, so that broadcasters can get a good understanding of how to get that consistent experience between what you're doing on the air versus what your listeners are seeing on the stream, and having a consistent experience. Just a couple of television updates. I try to keep abreast of what's going on in the US with the deployment of ATSC 3.0, which is next-gen television. There are dozens now of US stations that are broadcasting ATSC 3.0. They're doing it by multicasting multiple ATSC1 stations on one tower by collaborating with other stations in their market. So they'll have multiple, what I'll call regular DTV stations on one tower, and then multiplexing the new technology ATSC3 on another channel until they get a large enough base of ATSC3 television sets in the field, and then ultimately a cutover. So this map is showing the regions that already have next-gen TV operating in those areas. The orange is the market areas that already have at least one ATSC3 operation in up in operation now. The dark blue ones are ones that are planning, and the turquoise one is one that is like ready to launch but not on yet. So you can see that it doesn't cover the entire country, but it's covering the majority of the population very quickly. Consumer products are available from Hisense, Samsung, Sony, and TCL. So it is out there. There are also little set-top box devices that you can buy for under $200 that you can get ATSC3 reception. The FCC has modified the broadcasting rules in the US to provide the flexibility for this simulcasting and multicasting of program services that broadcasters need in the transition. And the NEB is developing a broadcast positioning system that takes advantage of the ATSC3 system and the data casting capabilities that it has to provide an alternate time reference that can be used nationally across the country. And it's a really important issue because North America doesn't have a backup to the GPS satellite system. And apparently China and Russia do have rudimentary systems as a backup, but North America does not. And power generating stations and financial transactions through the banks come to a complete stop without the GPS time reference. So having an alternate service, and this wouldn't be a complete replacement to GPS that you use for navigation and the like, but it would provide a complementary service that could provide, just the time reference needed to keep critical services like the power grid up and running. So that's a really interesting development. And some broadcasters in the US now are proposing that there needs to be a sunset on ATSC1. So while the interest in Canada has not been high so far in making the conversion to next-gen TV, there could over time be some pressure from the US that that it's going to go that direction down there, and that will certainly impact us. But also the potential data casting opportunities are might be more relevant to Canadian broadcasters before that occurs. And in June of this year, I was able to attend IEEE BSMB conference, which was hosted by the Humber College Broadcast Broadband Convergence Lab. And the keynote addresses highlighted the ATSC 3.0 deployments and the data casting opportunities. So the president of ATSC, Madeline Noland, was there and talked about how diverse use cases drive innovation, and some good examples of that were Aaron Rutten presented the Smart City project that she's in charge of, which is going to be launching in Calgary, where they're using an experimental ATSC3 transmitter to run a number of projects that will provide communications to first responders so that they can have, as an example, if you had a really terrible fire in a factory plant, police, fire, and paramedics could have floor plans of the plant sent to them simultaneously, and they don't have that kind of communication capability now. There's also the opportunity to do distance education and like road sign controls and things like that. In the presentation, Aaron gave a great example of, if there was a terrible accident on the highway, then, if you're roaring down the Trans-Canada Highway at 110 and coming up on this accident, then everybody gets there at high speed. But with this kind of smart city project, they would be able to have electronic speed signs before you get to that event that could slow down the traffic flow before you get there and reduce the possibility of further accidents. So that's just one example. And then there was another keynote from a professor at the University of Shanghai who was presented some results on a complementary multimedia network to 6G using ATSC 3.0. And so it was kind of interesting to see how they were using just the reliability of reception and coverage that they could achieve by combining the benefits of 6G on low power, low tower cellular network and high power, high tower ATSC coverage to fill in, and each filling in any gaps in coverage or multipath from the other, and getting very, very high reliability of coverage. So there's some really interesting opportunities that are available. Potentially it can generate an additional source of revenue for television broadcasters as these things start to take hold. So it's something that I definitely keep a watch on. And that's all I've got for you this year. So thank you very much, unless there's any questions. Nope. Okay, thank you very much.
I have a quick question.
Yes.
In the map you showed that the ATSC3 is mostly in southern U.S. and less along the border and north toward Canada. Is that a coincidence, or is that...
Great. How do I get back there? There. Yeah. Well, no, the eastern seaboard is well covered. So, between California and the eastern seaboard, you've probably got half of the U.S. population there. But, yeah, you're right. The southwest is heavily covered and not in the north. I don't know why.
Just random, maybe.
I think so.
There's not a lot of population.
Interesting.
Yeah.
One block this or that.
Mm-hmm. Yeah. Yeah, certainly. There are some broadcast groups that have been more enthusiastic about the rollout than others, like the Sinclair Broadcast Group, for example, has been very keen on this. But yeah, other than the population density, then I don't know. Yeah. Okay. Thank you very much.
Okay. Kirk, we want to thank you very much for being here today and presenting this paper.
Okay.
On
Thank you.
behalf of the CCBE, thank you.